Okay, so now that we've got that, I'm going to erase all this and show you actually how to solve this. We're probably going to have to use this whole whiteboard twice, because working it out by hand is a lot of steps, a lot of work, but it is worth it. Okay, so let me write out the problem again. So remember, we're trying to maximize P is 30x plus 50y. Remembering that x and y are bagels and donuts. And we've got our constraints as 5x plus 5y is less than or equal to 35, and 2x plus 4y is less than or equal to 20, and of course, both x and y are positive. Okay, the first step is to graph our constraints. We're going to graph these three constraints. And so we need just our normal graph. We only need the first quadrant because that's the non-negativity constraints. We don't need our whole xy axis. And now let's graph these. So let's focus on the second one actually. So 2x plus 4y is less than or equal to 20. Now you've probably learned how to graph lines in the past, but just as a review, we're going to break this down and how to actually do this. So there are a couple ways you can do this. You can either put this into slope-intercept form or figure out some kind of mathematical way to get it into an easier form. But when it's written like this, which we call in standard form, number times x plus number times y is number, I find it easiest to actually use an intercept method, which basically means find your x and y intercepts. So the x-intercept, remember, is where it hits the x-axis. So in this case, it is where your y value is 0. So basically, we can just kind of ignore that middle part. I'm going to just put an equals for right now. So 2x is equal to 20, divide by 2, x is 10. So that means our x-intercept is the point 10, 0. So our x is 10, but our y is 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom. That is our x-intercept for our second constraint. Now let's do our y-intercept. Now again, this is where it hits the y-axis, so in essence, our x value is 0. So we can basically ignore that and say, for y is equal to 20, divide by 4 on both sides, and that leaves us with y is equal to 5. So that means our overall y-intercept is the point 0, 5. And then what you do is you just draw the line that connects those 2 points. And you don't have to keep going because, again, we don't have to deal with negative responses there. Now you notice that gives us the line, but remember, we have a less than or equal to here, which really means it is on this line or any point underneath. So if you have less than or equal to, you basically shade from the line to the origin, underneath that line. If it was a greater than or equal to line, then you'll see that it will go outward from the origin, or above the line. And that's always going to hold. And so you can do the same kind of process with the first line. It turns out that the x-intercept and y-intercept will be 7, 0, and 0, 7. But you can do the math there and figure that out too. 3, 4, 5, 6, 7. Here's 7, 7, and you connect those two with the line. Okay, and again, it's also a less than or equal to, so we shade underneath. Now, the interesting thing about graphing two inequalities is that we really only want the part shaded that matters to both of these. So I can go ahead and erase that little triangle there and this little triangle here. This part that's colored with both blue and purple is what we determine, or what we call, our feasible region. Meaning any point in that region or on those lines will work for both of our constraints. Because remember, our goal is to maximize profit, but we can't go outside either of these two constraints. If we're out here, that means we've used too much sugar and flour that we don't have. So we have to be in this region in order for our solution to even make sense. So that's our feasible region. And it turns out, and there's mathematical ways of proving that this is true, that the only points to find our optimal solution, meaning the point that's actually going to maximize profit, is going to be one of the corner points of the feasible region. So either this point or this point or this point or this point. We don't actually have to consider the infinite amount of points that are in the region. It's just down to those 4 points. So now our goal is to figure out what those 4 points are. 3 of them are easy because we've already found them. This is the point 0, 0, because it's the origin. This point is the x-intercept of our purple line, which was 7, 0. This line right here, that is the y-intercept of our second constraint, that is 0, 5. Now this point's a little tricky, and we could estimate it from the graph, but you don't usually want to do it. As mathematicians, we don't like to estimate. We want to know exactly what that point is in case there's some kind of fraction involved or something like that. So what we have to do is solve a system of equations. Back to our algebra class. So what we do is we take those equations, and I'm going to go ahead and write equals instead of less than equal to, because we're on the line now. So we have 5x plus 5y is 35, 2x plus 4y is equal to 20. We want the xy point that satisfies both of these. Now there are a couple different methods you can use, but the method I like to use is the substitution method. So we're going to learn that one right now. Basically what it means is take one of the two equations, solve for either x or y, substitute it in the other one. So I'm going to take our first equation and I'm going to solve it for y. I'm going to say y equals something. So I'm going to move the 5x over. So we have 5y is 35 minus 5x. And then we just want y, so I'm going to divide each number by 5, or each term by 5. And we're going to get y is 7 minus x. Worked out really nice. We can now take that and plug it into our second equation. Meaning we replace the y here with 7 minus x. And then we solve from there. So I'm going to distribute this 4, get 2x plus 28 minus 4x is equal to 20. Combine my like terms, so 2x minus 4x gives us negative 2x plus 28 is equal to 20. And then I can subtract the 28 over, get a negative 2x is negative 8. Divide by negative 2, and we get that x is 4. Now, of course, remember we need an xy point. So we take that 4, plug it into our solved y equals equation, and we get y is 7 minus 4, which is 3. So this point right here is the point x equals 4, y equals 3. And there we go. That gives us that meeting point right there. So what do we do from here? Well, now we're going to actually use our objective function. I just erased the 7, 0. That's fine. I'll go back. So I'm going to set up a little chart. And it's going to have the xy point. And it's going to have the objective function. So p is 30x plus 50y. So I'm going to list out our corner points here. So 0, 0, 0, 5, 7, 0, and 4, 3. And then I'm going to take those, plug it in here, because this is an x, this is a y. So p is 30 times 0 plus 50 times 0, which is in fact 0. Probably not going to be our maximum. Here we've got p is 30 times 0 plus 50 times 5. That gives us 250. Here we've got 30 times 7 plus 50 times 0. That's 210. And then we've got 4, 3. So we've got p is 30 times 4 plus 50 times 3. 150 plus 120 is 270. So we notice that point has the maximum profit. So our final answer, having done all of that work, is we maximize profit. Our max profit is going to be $270. And that comes from selling 4 batches of bagels and 3 batches of donuts. It's really important that when you state your solution, you go back in terms of the problem, in context of the problem. So that's your profit, that's going to be your max profit, and it comes from making 4 batches of bagels and 3 batches of donuts. And there we go. That is how to do linear programming. So this was the first type of problem that they bring up in the chapter. The other one is a minimization problem, and you'll notice that most of those will be going out from the origin. You'll have a lot of greater than or equal to inequalities in your constraints. But as you continue through this course, these problems will become trickier and trickier. You might have more variables to deal with because you'll make more products, or you might have more constraints, or sometimes you'll have a mixture of greater than or equal to, less than or equal to in your constraints. But the process is all the same. You figure out what your feasible region is, and then you figure out what those corner points are, and then you use that in your objective equation to figure out what the profit or cost actually is. So hopefully that was helpful. In lieu of writing or graphing out the things by hand, if you're allowed to use technology, learn how to graph inequalities on your graphing calculator. It's pretty simple, pretty straightforward. And there's also, if you don't have a great graphing calculator, there's a website called desmos.com, D-E-S-M-O-S, where you can just type in the inequalities and it will graph it for you, and you can just kind of click on the intersection points to figure out what those corner points are. It's a really useful tool, highly recommend it. But hopefully this is helpful, and then stay tuned because the next video we'll be talking about how to actually put that into Excel. So, good luck.